Hello everyone, my name is Vincent Ducatteeuw and I'm a PhD student at the History Department of Ghent University in Belgium. In this talk, I will present the data model for an urban gazetteer using CDOC-CRM as a top-level ontology. I argue that an urban gazetteer can be a valuable tool for structuring and analyzing urban historical data. The model I propose will closely follow the linked places format for gazetteer data in order to ensure interoperability with other gazetteer data sets. To be accordant with the FAIR data standards, the information will be published as linked open data, and the gazetteer will be searchable using Geospatial. So the first question that warrants an answer is, what is a gazetteer? Well, gazetteers are commonly understood as geographical dictionaries. They are documents used to disambiguate places by uniquely describing them. This is often done through the provision of geographical footprints, or providing geospatial information linked to these places, such as an address, place name, or a place type. Due to their content, gazetteers are a useful research tool in digital humanities, both for the retrieval or structuring of geospatial information. The image on the right showcases the gazetteer of the city of Ghent and the province of East Flanders. It is a historical gazetteer containing place information data such as where services and professions are located in the historical city. Gazetteers are also often provided as an addition to maps in order to improve the reading of these documents. In this example, the gazetteer alphabetically organizes based on place name and place time. The digitization of this gazetteer, together with the georeferencing of the map, would make it possible to use the place information for spatial analysis. It will also make it easier to systematically compare maps and deconstruct both their meaning and power. The growing link between the semantic and spatial domain resulted in the creation of digital gazetteers. These gazetteers function as knowledge organization systems, structuring information based on geographical coordinates and semantic spatial relations. Today, both the public and private sector rely heavily on large-scale gazetteers such as GeoNames, OpenStreetMap, and Google Maps. However, many existing digital gazetteers are not granular enough for researchers interested in urban history. Historical sources such as census data, address books, or city directories would be more accessible when linked to historical gazetteers with a high level of granularity. Currently, historical gazetteers such as World Historical Gazetteer and Pleiades do not have an intra-urban focus. Some historical data requires a smaller, more detailed scope, for example, focusing on streets, buildings, and squares. If we could solve this granularity problem using urban gazetteers, historical data would be made more accessible to analyze further. However, at the moment, there are only very few examples of urban gazetteers. One case that, however, can be mentioned is the map of early modern London by the University of Victoria. This project opens up the Civitas Londinum map by annotating places visible on the map and linking them with occurrences in literary documents for the Shakespearean era. It exemplifies how urban gazetteers as a tool can be useful in humanities research. The underrepresentation of urban gazetteers, especially compared to large-scale gazetteers, can be partly explained by the higher complexity. Although both types deal with geotemporal properties of places, these properties become more difficult to work with on a detailed scope. Questions surrounding place disambiguation, hierarchy, place typology require further study. In this talk, I will briefly discuss the issue of place disambiguation, as digital gazetteers require a formalization of place in order to model and aggregate place data. Place disambiguation refers to the issue of place identity. In order to assign stable identifiers to places, a place concept should be defined together with identity criteria. These criteria determine what a place is and how a place can change. This is determined by the ontological assumptions researchers such as I make when deciding if a place maintains or loses its identity through change. These assumptions are closely tied to a place definition that is used by the researcher. However, theories about place and identity criteria that take into account linked open data measurement are sparse. In GIS research, place is often not clearly defined, nor is there a consensus on how to deal with it. However, it is an important distinction as a gazetteer tries to incorporate both space and place. Starting from the 1970s, some human geographers started to make a distinction between space and place, whereas space can be viewed as a geographical container lacking any additional qualities, place is space made meaningful. Space is limited to a geographical shape, encompassing an area that can be clearly defined using coordinates. Place, on the other hand, is geographical location imbued with meaning through human experiences. Both are central to gazetteers, as historical place can be encompassed or contain many spaces, and both space and place are valuable to discover and analyze historically. In Identity of Historical Localities in Information Systems, Garbage et al. Discuss how to define identity criteria of localities, specifically settlements. And they do this specifically in a database management context. So based on the ontological assumptions of researchers, they conclude that localities have 4 crucial identity criteria, namely proper name, geographical location, type, and L-mereology, which can be defined as the part-whole relationship between different localities. The authors are of the opinion that the identity of localities are influenced by events. If it is the case that due to an event in which the locality participates, the proper name and one of the 3 mentioned criteria is changed, the place is changed and is different from the place before the event occurred. For my own research, I'm testing if this reasoning, based on the proper name, the location, the type, and the part-whole relationship, can be suitable and if it can be applied to urban places. When dealing with spatial properties in the context of linked open data, the use of vocabularies and ontologies is necessary. In GeoHumanities, the linked places format is becoming a de facto standard for structuring historical linked open geodata. LPF is aimed to be an interconnection format for gazetteer data. To ensure interoperability, the Urban Gazetteer model closely aligns with LPF. It would also be worthwhile to investigate if LPF can be mapped to SIDOC CRM terms, as CRM is an upper-level ontology for the semantic integration of cultural heritage data, and could ease the adoption of the LPF standard in cultural institutions familiar with SIDOC CRM. Linked places format is designed around JSON-LD, using an experimental extension called GeoJSON-T to standardize the geotemporal properties. The GeoJSON-T when element enables a spacetime framework necessary to uniquely describe a place, even as features of the place change over time. This is crucial for a gazetteer. So the LPF design facilitates several of the challenges digital gazetteers face with geotemporal data. The model proposed here attempts to closely align with the structure of LPF, but it is defined using classes from the SIDOC's conceptual reference model. An extension for geoinformation called CRM-HEO introduced the concept of spacetime volume, which is essential for modeling spatial temporal properties in SIDOC CRM. The model of the CRM-based gazetteer for medieval and early modern places has been discussed by Schneider et al. The urban gazetteer presented here modifies their reasoning around the concept of spacetime volume to further align it with the linked places format and CRM version 7.1.1. The model is built around CRM class E92 spacetime volume and its subclass E93 presence. A historical place is defined as an instance of the spacetime volume class. Together with associated properties and classes, spacetime volume can be used to model the extent of a place in space at any moment in time. For the urban gazetteer, place data is derived from observations. An observation is derived from a historical source mentioning place information. This can be modeled as an instance of the class E93 presence. This is a subclass of spacetime volume and can be understood as the spatial extent of a place, but fixed in a point in time. Place observation A, in this example, is derived from a historical source, and this historical source mentions the time span and the spatial extent of the place. This slide illustrates how to model street information in the Urban Gazetteer. In the example, a map from 1855 mentions the Sint-Pietersnieuwstraat in Ghent. This information is modeled as a place observation, an E93 presence. The map is defined as a document recording the place observation. The time span for the observation is implicitly derived through dating of the map. The map also contains a gazetteer mentioning that the place in question is of the type street, which we can model as class E55 type. The French appellation, Rue Neuve Saint-Pierre, can be defined as an instance of E41, E33 linguistic appellation. Lastly, as only the place name is different, but the place type, location, and part-whole relationship remains the same, this observation can be interpreted as a presence of the Sint-Pietersnieuwstraat space-time volume. This enables us to link multiple historical observations of the same place to the same entity, namely the space-time volume. Important to note is that every piece of information that is derived from the same source is part of a unique presence. This is a crucial principle for the Urban Gazetteer because sources can contradict each other. If another historical source mentions place information, a new presence is required. So the following slide contains an image of the full model, but do note that this model is still in development and prone to change. There are two main differences compared to the previous slides. The first is the addition of the Geospatial mapping. To maintain compatibility with the Geospatial standards, certain CRM classes are mapped to Geospatial classes. This allows us to represent and query geospatial data through the use of Geospatial. You could, for example, infer topological relationships between historical places based on geometry data. The second difference is the addition of additional E31 document instances, referring to AAAF annotations. One of the main ideas of the Urban Gazetteer is that AAAF sources are used in the data creation workflow. These annotations can be part of the stored data provided in the database to have a visual link between the original source and the digitized data. To give an idea, we could have a georeference AAAF map with the AAAF annotation of the building. This AAAF annotation can document the geometry of the place observation and can be visualized. The data model is currently being tested using a corpus of datasets about streets in Ghent. These were mapped to CRM classes and converted to RDF. Subsequently, the graph data was uploaded in TripleDB, an RDF triple store supporting Geospatial. The second image illustrates how street geometries derived from the 1855 historical map can be queried and be visualized using the Yazguri Sparkle editor. Lastly, the model is certainly not finished. There are ongoing challenges that need to be solved in order to improve the Urban Gazetteer as a tool for humanities research. One of the next steps is to identify urban identity criteria and also create a place disambiguation method. This is crucial for the aggregation of place observations and the creation of stable identifiers. A second question is about the data creation workflow. To reach a critical mass of place data, an efficient method using AAAF needs to be developed. Many interesting projects are relevant to this challenge, such as machines reading maps and all maps. The first project researches how to make text on maps and accessible research using machine learning. The second project is focused on georeferencing AAAF maps. The AAAF Maps technical specification group is also working on an extension for georeferencing and geotagging AAAF images, which would certainly help with the data creation. Lastly, it is also possible that researchers have different interpretations of the same source. At the moment, the Gazetteer cannot adequately implement different assertions based on the same source. This would be necessary in the future. And lastly, thank you for your attention and for the honor to present for GeoHumanities'21. I look forward to the valuable feedback and possible collaborations with other researchers. Thank you.